Hello, dear students. I'll tell you an awesome way to revise for your upcoming examinations. Suppose you're in 12th, right now the chapter that would be going on is current electricity or magnetism. If you're in 11th, chapters that would be going on for you is work power energy. Okay, if you're preparing for JEE mains or advanced. And so you'll be having tests, right? And before test, you want to revise once. So you just want to, have a look at the formulas before the test. So an awesome application is the Formula Racing J Revision application in the Play Store. And so you can go to revise formulas. And right now you all will be in current electricity. So go to current electricity and you see all the formulas are there here. So it is a good revision before your test. And you can also just pin the formulas so that it comes up. Okay. You have it even for chemistry and mathematics also. Okay. Next, if you just feel reading the formulas is not that much fun, you can play with your friend. Okay, you can host a match and you can play with your friend, and it'll be a short game of just formulas, and you'll have fun playing it with your friend, and that way you can revise nicely. Another beautiful feature is that suppose you have attempted a chapter and you make many mistakes, all the mistakes are stored, and there's a if you click this panda you get messages of how you have done. So here it is saying you don't know fluids, watch a tutorial. That means I've attempted fluids and I've done only 36% of the questions correctly. So it is saying watch a tutorial. Okay, and so this is an awesome application that is there in Play Store, and it will help you immensely for your revision, and not just help you for revision, it will make it fun also. Okay, so play the game, tell your friends, enjoy, have fun while doing your revision. This is a question from J Advanced 2025. Okay, so first I'll explain you the question. There are two metallic cylinders. Okay, so this is one cylinder, this is another cylinder, this is another view. Okay, and inside the space between the cylinders there is a dielectric constant of 5. Okay, now there is a plane. This plane you see, there is a plane, and this plane is placed at a distance r from the center. Okay, we need to find what is the flux, electric flux through this plane. Okay, and another thing that he has given is there is a charge on the inner cylinder. There is a charge q. Okay, there's a charge q on the inner cylinder here, and the outer cylinder is earthed. So obviously they are saying that on this outer sphere there is a charge minus q. Okay, so we need to find what is the flux through this. What I'll do is I have divided it into three parts, and let us do each part so that your understanding will be better. See, first we'll do if there is no dielectric, the question. In the second part, we'll do if there is complete dielectric, that is the JEE advanced question. In the third part, we'll see only if there is, half dielectric, what will be the answer to the same question. Okay. So let us see the first part. So we have this plane here, and we need to find what is the flux through this. So I'll just construct this. Okay. Okay. This is one line from here to here. This is one line from here to here. Okay. Now, how will the flux be? Tell me. Inside this cylinder, there will not be any flux. There will only be flux from here to here, like this. So there will be flux like this, outside, radially outward, here like this. Okay. So now, if I consider this plane, and this plane, the flux through these three will be q enclosed by epsilon naught. And we know that here the field will be radial from here to here like this. So the flux through this plane will be anyways be 0. The flux through this plane is also 0. The flux in this enclosed surface will only be through this plane. So if we can find what is the charge inside this enclosed surface, we can find what is the flux through the plane. Okay, so first let us find what is the charge inside this enclosed surface. See, the flux, there will be charge here everywhere on this. It won't be there this side, it will be there this side. Okay, plus will be there this side. For readability sake, I have kept it here, but this plus will be there on this side of the surface. The minus will be there not outside but inside here. Okay, so now I need to find what is the charge here and what is the charge here. Okay, so what I'll do is I'll just draw it like this. This is R, And I'll draw another line here like this. This is 2 root 2 root 2 r, and this is 2r. Okay, so I need to find, so if this is root 2 r, right, if I find what is this angle alpha, I can find r into alpha is this length and r into alpha is this length. So what I'll say is flux equal to q enclosed by epsilon naught. Okay, what is the total charge enclosed by epsilon naught? So what is the charge, tell me? So the charge for this whole length is q by 2 pi. That is the charge per unit angle which is there here. It is a long cylinder like this, per unit angle this is q by 2 pi. Into what is the angle here? Here it is alpha, and here also symmetrically we can say it is alpha. So can we say that this will be 2 alpha by epsilon naught? Okay, so this will be nothing but q alpha by pi epsilon. So if I can find what is the total charge inside, I can get what is the total flux. Okay, so now this angle we need to find. So this, what is this angle? Tell me. This is root 2 or this is that? This is 45 degrees. Okay, and you see this triangle 2r and r, so this whole thing will be 60 degrees. So what will be this angle? Tell me. This angle will be 15 degrees. 10 degrees is nothing but pi by 12. Okay, so if again, what is pi by 12 equal to q by pi epsilon naught? This is pi by 12. Cancel out, I'll get this as q by 12 epsilon naught. So this is a case 1. This is the first case where there is no dielectric. Okay, so let us slowly move on to the one where there is dielectric. So again, there is a dielectric here, and there is a charge q which is there, inside this here. And now because of the dielectric, there is a, what you call, induced charge here, a negative induced charge here, and a positive charge here. Okay, so now again we'll take the surface. We'll take the surface. The, what do you call, the flux will be the total charge here divided by epsilon naught. So flux equal to, what was the charge, tell me? Here it was q by 12 and here it was q by, total it was q by 12 epsilon naught. Now because of the dielectric, what happens? Field everywhere becomes E by k. That means the total charge here, that means charge here is q on this. In the dielectric, this plus the dielectric will become q by k. So it will be q by 12 epsilon naught, and the whole thing becomes by k. So here the k is 5. So it becomes q by 60 epsilon naught. Okay. So that is the answer to the JEE advanced question. Let us move on to the next case. Okay. So you can see half is filled with dielectric. Okay. Now we know that the total charge is not distributed uniformly if there is a dielectric. See, this and this whole thing is one capacitor, and this whole thing forms one capacitor. And we can say that these both capacitors are in parallel because the potential difference across these two is the same. Okay, so if they both are in parallel, how will the charge distribute? Tell me. Suppose this capacitor had capacitance C, this capacitor will have capacitance Kc. It's because there is a dielectric field here. So obviously there will be more charge that goes here, right? So what can we say is, if a charge X is distributed here, here the charge distributed will be K into X. And what is the total charge that is there? The total charge is Q. Okay, so we can say Kx plus X equal to Q. See, here we are only telling about the free charge. We are not talking about what is a bound charge here and all that. Just the free charge that goes, that redistributes on the conductor here. Okay, so what is X here? X equal to Q by K plus 1. Okay, so we know that here Q by K plus 1 is distributed here, and here kq by k plus 1 is distributed. Now, knowing that the potential drop across this and the potential drop across this is the same, obviously the field at any point here at some distance r and the field at some distance r here will also be the same, right? Which means, see, we have q by k plus 1 uniformly distributed here. Here we have kq divided by k plus 1 here. Okay, but see, but what will be the induced charge here? Tell me. This plus this induced charge will be equal to q by k plus 1. The reason being, electric field must be the same, at every point, at any point at a distance r from here. So what can I say? Tell me. I can say that the total charge here, that is this induced charge plus this charge plus this charge. The total charge, this includes what? Tell me. This includes charge on conductor plus the induced charges on conductor, equal to charge on conductor plus induced charge on dielectric, where on the inside conductor, this equal to 2q divided by k plus 1. Why q by k plus 1 is here? This plus this also must be q by k plus 1. Why? Because the field must be the same. Okay. Now this is the total charge. Now for this total charge, we need to find what is the charge here and what is the charge here. That is it. Okay. So what can we write the total flux? Tell me. So total flux through our plane, what is the total charge? 2q divided by k plus 1 is nothing but 6. And this is the charge per unit angle is how much? 2 pi. Okay. And what is the angle through this angle and through this angle we require? That is pi by 6. Okay. So pi by 6 into pi by 6. This is the total charge which is enclosed, within this part and this part that we had already seen, divided by epsilon naught will be the total flux. Okay. So if you just cancel out this, you will get q divided by 36 epsilon. Okay. So you see, in the first case we got q by 12 epsilon naught. In the second case we got q by 60 epsilon naught. We are getting this midway, q by 36 epsilon naught.